Good morning, I am Renu Sharma, Assistant Professor EC Department. Today I am going to start with the next topic of the subject, that is wireless and mobile communication for the unit 1. So the contents of my lecture for today is why we have to consider this wireless cellular technology, what is cell, all about cell, its cluster, how we can calculate its cluster size and all. So all this thing we will going to calculate today. We will see the formula, then cell splitting we will see, then frequency reuse concept and reuse distance calculation. We'll see cellular system components. There are the different components are there for calculating the cell architecture, then antennas that are used for mobile communication, operations of cellular system and handoff, then channel assignment, sectorization and so on. So these are the contents or the flow of my lecture. So we'll start with the introduction, that is the concept of trunking or resource sharing between two central telephone exchanges was used in the conventional landline telephone system. So before mobile communication, which is a kind of almost a radio wireless communication technique, we are using landline telephone system. So that is a conventional landline telephone system, which is, first thing, it is wired and we have to connect wired. The handset is also connected with the receiver. Secondly, it is used for short distance communication. The connectivity, when we are talking about for the long distance communication, it is not quite good. So we are moved towards the wireless communication system, which is the example is mobile phone. So the concept of trunking is basically when we are sharing the resources which are available, which has to be used between the transmitter and receiver when more than one user are there, then resource sharing is there. So between two central telephone exchanges, there is an exchange of information will be there. Now a trunked radio system is a complex, centrally controlled and full duplex radio system. So first thing is that in case of mobile communication, we are using the full duplex concept. What is full duplex? There is a transmitter and a receiver is there. It will going to transmit the information in this direction and then transmit the receive the information in this direction. So this is the concept of full duplex communication, which is majorly used in our mobile communication system. Now that allows the sharing of limited radio frequency channels among a large group of users. So it's control or signaling channels as well. So apart from sharing the resources which are available for a particular communication, we are also sharing control signals, signaling information, means along with the voice signals, we are also sharing the control signals. So signaling we are using. So this is the concept that has been used in the mobile communication system, the trunking operation. Now the concept of cellular technology encompasses various aspects of infrastructure, for instance division of area, frequency management, allocation and call handling. So what you'll see in the next slide also, that if I consider this room as a geographical area or a city as a geographical area, then to provide the wireless communication, to provide the connectivity between the transmitter and receiver, each geographical area is divided into different cells. Now these cells are having the shape of an hexagon. We'll see in the next slide also. Now these hexagons are been connected together. So we can see that these are the three cells. This is cell number 1, this is cell number 2 and this is cell number 3. So these are the three cells which are means a geographical area is divided into different cells. So this is cell 1, this is cell 2 and this is cell 3. So this is the division of particular geographical area. Now, following are the two major components of the mobile telecommunication system in general. Now, first two things that we have to consider is, first one is the central station. Now, this is common for many subscriber and includes the switching equipment and an RF transmitter and a receiver. So, this is the concept that we are using for the central station. Now, second is mobile telephone. Like every subscriber must have a mobile telephone that includes a microphone, a speaker, a dialing facility, a radio transmitter and a receiver. So, this is the concept of central station and mobile telephone. So, what we are considering here. So, this is the these are the two main components of mobile communication system, central station and the mobile phone. Central station is also known as base station, BSS. It is also known as BSS. So, at the center of every cell there is a BSS which is installed, or we can say a base station which is installed, to which your mobile phone or the device is connected. So, this is the way of connecting the mobile phone with the central station. Now, next is the cellular infrastructure. In modern cellular telephony, rural or urban regions are divided into areas according to the specific provisioning guidelines or the standard protocols. So, whatever we are considering, first thing, that any geographical area is divided depending on its population. So, that's why the two terms are used, that is rural and urban. So, as we know that the population in this area is less as compared to the urban area. So, this is the difference in the population. So, this is how this geographical area is divided. The deployment parameters such as amount of cell splitting, cell sizes are determined experimentally in the cellular system architecture. Now, provisioning for each region is planned according to an engineering plan which includes cell clusters, frequency reuse and handovers. So, in case of any region, related to a region, there are different concepts are there, like the cell. Now, the combination of cell are known as cluster. We are going to see that how clusters are calculated. Then there is a frequency reuse concept is there. What is frequency reuse? Let's say this is a cell. Now, this cell is divided into different let's say these are the three cells. Now, the frequency, set of frequencies which is used by this cell can be used by this cell also, but at some distance. So, there is a distance is maintained between two cells which are using same set of frequencies, and for full duplex communication we require a set of frequencies for the purpose of communication between the transmitter and receiver, and from receiver to the transmitters. And also one thing that has to be noted, what is handover? Handover means since we are discussing about the mobile communication, the transmitter and receiver both are moving in nature. When the transmitter can move from one place to one cell to another cell, which means let's say this is a mobile phone which is been determined to this cell only. So, this will act as a home location register, and when this mobile moves to this cell, then this will act as a visitor location register to this particular mobile phone. So, home location register means this cell is having all its information related to this mobile phone, and this cell is having the information which is moving from this place to this cell. So that is known as visitor location register. So, whatever control signal or the voice signal is associated with this base station has to be transferred to this base station. So, that is known as handoff or handover. So, that is the concept. Whenever a mobile phone is moving from one cell to another cell, then the transfer of control signals and the transfer of voice signals is being accomplished from one base station to from the parent base station to the another visiting base station. So, that procedure is known as handoff. We will discuss in the slide also. So, today software tools are also available to plan and design the cellular architecture. So, any area which is to be divided into different cells will be divided using a software. A software is also there because it is not possible to manually divide a area into different cells. Now next is cell. A cell is a basic geographic unit of a cellular system. The term cellular comes from the honeycomb hexagonal shape of the area to which the coverage region is divided theoretically. So this is the concept that I am saying, that it has to be divided into different cells, and the size the shape of the cell is hexagon. Now cell wise, one base station provides transmission over a smaller geographical area. Cell sizes vary depending on the landscape. Basically, it depends on the population size. Whenever the population size is less, then bigger cells are considered, and whenever the population is very high, then smaller cell size is considered, so that the connectivity to the large population can be provided when we are considering the very small cell size. So that is the concept of this one. Now, due to the constraints imposed by natural terrain and man-made infrastructure, practically the cells are not perfect hexagons. So every time to divide a area into perfect hexagon is not possible, because maybe mountains, valleys and plains, these will be in between on the boundary of the cell may occur. So that's why the perfect hexagons are not possible. Now next is the cluster. This is what I am talking about. If I consider these are the cells, these are interconnected cells, and these 7 cells will make up a cluster. So n will be equals to I square plus j square plus ij. So what does it mean? That I and j, these are the two positive integers that we have to consider. It may be 0 also, but it should not be negative, first thing. And what do you mean by I and j? I means if I consider this cell as a center, so I have to move. If I consider I is equals to 1 and j is equals to 2, then how it has to be solved? So I means I have to consider this place and move to its center with I is equals to 1, then rotate 60 degree and I have to move 1 and I have to move second. So whatever cell which is present here, this one, this is considered as the main cell. So I means I have to move vertical upward, then rotate 60 degree clockwise direction and move 2 steps slant direction. So this is the concept of I is equals to 1 and j is equals to 2. So these are the cluster size that we are calculating. So if I consider I is equals to 1, then j is equals to 2, then n will be equals to 7. So that's why this cluster is made up of 7 cells. So this is the concept that we have seen over here, how to calculate the cluster size. So this is very important formula to calculate the cluster size of a particular area. Now next is reaching to the co-channel cell. So this is the formula that we are also considering for reaching to the co-channel cell. So I and j should be non-negative integers. I means vertical move and j is equals to slant horizontal move. So if I consider I is equals to 2 and j is equals to 1, then I have to move I is equals to 2 to this position and 60 degree rotation to the slant side, and j is equals to 1. So this cell and this cell is the co-channel cell. So the relationship exists between the cluster design equation and the frequency reuse as well as the reuse distance. So this is how we have to calculate the reaching distance. Now next is, this is an example which is showing that the area of a hexagonal cell is 2.598 r square, where r is the radius of a particular hexagon. So this is a hexagon as we consider here, and this is if it is divided into 6 sectors, then this is the radius of a particular hexagon. So a hexagon is made up of 6 triangles. You can see over here, this is first, second, third, fourth, fifth and sixth. So these are the 6 triangles in which the particular hexagon is divided. So from the geometry of the figure, then A is equals to r cos theta. If I consider this as an A, then from this geometry it is A is equals to r cos theta, and A by r is equals to cos 60 degrees. So which is can also be is equals to half, or A will be is equals to r by 2. So B square will be is equals to r square minus r square by 4. So area will be equivalent to 6 into area of the triangle. So this is how we from considering the geometry of a particular hexagon, this cell size is considered as 2.598 r square. So this is the radius of a particular hexagon shape. Now next is the cell size. How we have to calculate the cell size? The size of a cell depends on the density of the subscriber in that area. So I have told you earlier also that it is inversely proportional. If the number of area or the subscribers is high in a particular area, then the cell size will be reduced. If it is low, then it will be high. So this you can consider from here also, like macro cell, micro cell, pico and femto cell. So as we know that the cell size is decreasing with the increasing number of population. Now next is the cell splitting. Cell splitting, you can see over here that small cells are considered for the urban areas where the population is quite high, and large cell are considered for the rural area. So you can consider over here that when the population is quite less, then the large cell size is are considered, and this is for the small cell for urban area. So this is the consideration for cell splitting. Next is cell frequency reuse. Now you can see over here that the radio channel consists of a pair of frequencies for full duplex communication. As we all know that in case of mobile communication, we require a set of frequencies, one for the forward channel and another for the reverse channel. Forward channel is from the base station to the mobile phone, and reverse channel is from the mobile phone to the base station. The concept of the frequency reuse is based on assigning to each cluster the same group of radio channels used within a small geographical area. A set of n different frequency groups like F1 to Fn is used for each cluster of n adjacent cells and shared among the cells equally. Now the coverage area of the cells is called the footprint surrounded by outer boundary of the cell. So whatever geographical area is divided into cell, that particular area is divided is known as the footprint that has been covered by the particular cell. So if there are 7 members in a cluster, the number of available frequency sets is equivalent to 7, and the frequency reuse factor is given by 1/7. So this means that each cell uses 1/7 of the available cellular channel for reuse. So this is the concept of cell frequency reuse. Now next one, this is the formula. This is very important formula to calculate the total effective number of channels, that is given by C is equals to M into L. Now what is L? L is the total number of duplex channel available for the reuse. Like for reuse we require one forward channel, another is required as a reverse channel. Then K is the number of duplex channel allocated to each cell of a cluster, that is denoted by K is less than L. N is the cluster size, which means that in a particular cluster how many cells are there. Like this is a concept of 3 cells in a particular cluster, and this is for the 7 cells form a cluster. And how this is calculated? This will be calculated using a formula, N is equals to I square plus J square plus Ij. This is the formula to calculate the cluster size. M is the number of times the cluster is repeated. Like you can see that here cluster is repeated 1, 2, 3, 4, 5, 6 times in this area. It is repeated. C is the total number of effective duplex channels available in the particular area. So that is being known as L is equals to K into N, or C is equals to M into L. So C is equals to MKN. That is the very important formula for calculating the total effective number of duplex channels. Now next is the reuse distance calculation. This is a formula to calculate capital D, and we have to show that D is equals to under root 3 I square plus J square plus Ij, that is N into R. So what we have to consider that D is equals to under root 3N into R. So if we consider this using the geometry of a particular cell, then I by 2 square will be equals to r square minus r by 2 square, or we can also write it as I is equals to under root 3 into r, that is center to center distance that we have to calculate. So this is the minimum distance between the two base stations in the vertical direction. Then using the cosine and the hexagonal geometry, I1 will be equals to under root 3 Ri, and GA1 it will be equals to this one, considering theta is equals to 120 degree, because if we are dividing a cell into six sectors, six particular sectors, then it is angle is equivalent to 60 degree, and if we are dividing into 3 sectors, then it angle is equals to 120 degree. So d square will be equals to I1 square plus J1 square minus 2I1 J1 cos theta. So this we can calculate that d square is equivalent to 3r square into n. So that is the formula for reuse distance. Now next is real world cell. You can see in this diagram also that how this real world cells are there, like this is connected in a cell, this is connected in a cell, this is in the cell, and this is also connected in a form of cell. So these are the real world cells which is divided into different areas. Now next is cellular system calculation. So in this we are seeing 3 different types of cellular systems. Like first one is the analog circuit switched cellular system. So first we will see what is circuit switched. Circuit switched is related to networks, network theory. Like if area is divided into into different cells, and we are considering a network only, like this is first node N1, this is node N2, this is N3, and this is N4, which means 4 computers are connected to form a network. Then to reach, let's say this is a transmitter and this is a receiver, and to reach from this place to this place, there are 2 options available, like from this to this option is available, or this to this option is available, and this to this. So basically there are 3 different paths are available between the transmitter and receiver. It is considered that this will follow the path length for this case, first, second and third. For the first and third case, the path length is same, and for the second case, the path length is less. So this is the consideration for the analog circuit switched network. This is not pre-decided. So this is also known as mobile unit or mobile subscriber unit, denoted by MSU, cell site or base station, and this is the concept of analog circuit switched cellular system. Next is digital circuit switched cellular system. In case of this digital circuit switched cellular system, it is known as mobile station, base station, or the base transceiver station. Transceiver, it is meant by transmitter and receiver. Then switching subsystem is there. Now in case of this packet switched cellular system, it has 6 elements. Now what are the 6 elements? First one is the user equipment, that is denoted by MS, mobile station. Then there is a base station in which it is considering BTS, base transceiver station, or base station controller, or base station subsystem. So all 3 are interconnected to each other, that is related to the base station only. Next is radio network controller, RNC we require, service support node we require, then gateway support node, and charging gateway function. So these 3 things we require for the packet switched cellular system. In case of this packet switched cellular system, this is different from the circuit switched because in this case we are transferring the data in the form of packets. So that is the case for packet switched cellular system. So this is all about the mobile station cell, how the clusters are formed, how it is divided into different cell areas, then how this formation will be done. So thank you for this lecture.